Hey, good morning. What an intro. That's really amazing. Someone put some work into it.
Yeah, yeah. So that was Camila who did that. So yeah, it was a good intro. Okay, so welcome to the Kubernetes Sri Lanka Q&A session with Kelsey, and I'm Nilesh. And joining with me today would be Binura as your hosts. And we are going to start asking questions with Kelsey. And if you have any questions, the Slido link is there, or you can just type in your questions on Hangouts Meet Messenger, and we can get started. So, Kelsey, um, as the first question, I'm just gonna take the cat out of the bag. So, as a fellow GCP advocate, what are your thoughts on the recent price change in GKE? I mean, we used to have master nodes for free, but now there's an hourly charge that's added for GKE control plane. So, what was the sole factor behind it? What was the reasoning for that?
Yeah, so when Kubernetes came out or GKE came out, I think almost 4 years ago, there was a charge. We used to
Hmm.
charge money for the control plane, the whole setup, and then over time, we decided to make it. I guess you would say the control plane for free. You just pay for the machines. In that same time between the price switch to zero to where we are now, where we do charge, there was a lot of features added. Things like binary authorization. We have vertical pod autoscaler, gvisor, regional clusters, all of these access control components for the control plane itself. There were just so many features we kept adding, but at some point, you can't keep that price $0, right? Because it's not $0 to us. It's not $0 to SRE. It's not $0 in terms of the investment we kept making beyond just open source Kubernetes, right? To add all of these things are a bit outside of what you get from a core Kubernetes offering. So we decided to put a price on there to accommodate like the cost that we incur for running that. And you can also see within the market, Amazon charges for the control plane. Azure can charges for the control plane now. I think it's one of those things that it really needed to reflect the value that you were getting. So this is why that price for the control plane component was added in order to kind of make sure that it was going to be sustainable. You know what I mean? To keep making sure that we're investing those features. Also, I don't think most people want it to be charged necessarily a la carte for every single feature like gvisor and all these extra things. There are some things you just expect to be there in GKE. So think of it as in some ways, somewhat of a kind of like a bundle pricing just to make it easier to adopt.
All right. Okay. That was a good answer. I was okay. All right. So we have the top questions here. So do you want to pick one up, Kelsey, or should we just have sort of like a conversation going on with the questions?
Yeah, I would just say ask them out loud just for, people that may not be able to read the screen, and then I'll answer from there. And also we could just break out into conversation as well.
Okay, cool, cool. So one of the people has asked that, what do you think is the biggest challenge solved by Kubernetes for developers? I think this is sort of like a starting question. So he's asking, do you think it's creating more challenges to developers than what they want?
So I've always maintained that Kubernetes is not for developers. And I know it's hard for people to think about because in many cases, we tend to leak our infrastructure to the developers, right? When we had virtual machines or even bare metal machines, we told developers, here's SSH, you can log in there and you can do things. And then when we had virtualization, depending on what your platform is, whether it was OpenStack, VMware, or even the cloud, you tell the developer, here's your credentials, you can log in, you can create virtual machines, you can use tools like Puppet or Chef. And so we've been leaking infrastructure to developers. We've been giving them this thing in the name of self-service for so long that every time a new platform comes out, like Docker, we always think that the developer should be running that infrastructure on their laptop, right? We don't really do that with the internet, right? When the internet, you say, here is your configuration for your computer. And transparently, they just use the internet infrastructure, right? Domain name service is automatically configured, their routes are set up, and then their laptop can participate in the network. One thing we don't do that for compute normally, right? Unless you're using something like Cloud Foundry or Cloud Run or App Engine. So when Kubernetes comes out, the first thing we do is say, hey, developers, even though you don't really care about this stuff, some people may, but what a developer ideally wants in their workflow, if it's not automated, is the ability to say, hey, here is my workload. Here's how much memory and CPU I need, maybe what region I run in, and ideally some way to do service discovery to find their dependencies. That's at a high level, ideally what they need. So when you say, here's Kubernetes, and you give them a bunch of YAML files, now you're actually giving them way too much that maybe the interface is too big. So to me, Kubernetes is good infrastructure. It allows us to layer our own platform UI on top, whether that's just some automation, Jenkins, Spinnaker, so forth, or just your CI/CD pipeline. So I think a lot of times developers are just being exposed to maybe a little bit too much. Depending on the developer, they may like it in terms of self-service. I make a YAML file or use something like Helm, and I allow my configuration to be run in Kubernetes. So the biggest challenge is, are we exposing too much infrastructure to developers? And that has always been a challenge when we think back to even virtual machines.
Yeah. Yeah. And like for new developers that are coming in, I remember in a KubeCon talk that you did, you made a joke that day that said that if someone wants to, if a person comes to you and asks that they want to send a rocket to the moon, and then they want to run this small service on that rocket, you as a DevOps engineer, what we are going to say is that we are going to introduce Kubernetes, we are going to introduce Istio, traffic routing and all of those things. And at the end of the day, that man just becomes exhausted and goes away. So that's the same thing. Yeah, it's happening with Kubernetes right now with a complex ecosystem. And sometimes developers just need a simple solution. And yeah, hello.
Yep, I can hear you.
Yeah. Sometimes developers need a simple solution, and sometimes Kubernetes and the ecosystem can be a bit of a challenge for a new person that's coming in.
Yeah, I mean, we're going to learn over time. Over time, we'll start to understand that at some point, we need to provide an interface that's focused on delivering software, not building platforms. So today, it's early. We're about 6-7 years in, depending on how you look at it. And right now, everyone's building platforms from scratch. Like all things in tech, we'll get tired of doing that. And my guess is we're going to start to really double down on more complete, ready-to-use platforms. They won't solve all problems, but I think that's just where we have to end up. There's no way we can keep adding and adding and adding all of these control planes, all APIs, all of this infrastructure.
Yeah. So with that in mind, so now Kubernetes is not the only kid in town. So there's Nomad is making a few headlines. Docker Swarm is there. OpenShift, it is based on Kubernetes, but I think it's an extension from Kubernetes. So what are your thoughts on those?
Just more infrastructure, right? So it depends. Again, and most of them all run on either Windows or Linux, right? That's it. So we still have the same two operating systems from 25, 30 years ago, right? So we're still pretty much doing that operating system thing. And now it's what workflow do you want on top of that? That's it. You can do it manually. You can just copy files around if you want to. You can use Puppet, Chef, Ansible, right? Those were the things before Kubernetes, Nomad, and all these other tools. When I look at these tools now, it's just, in my opinion, what workflow do you want? And depending on the workflow you want, you may prefer the abstraction.
I was wondering, as in, if the exponential growth of complexity in the Kubernetes ecosystem, was that one of the reasons that led to Google sort of pulling out Istio and Knative from CNCF? or was there like a different reason
I'll
for
answer
that?
that. So there's no pulling out. It was never there in the first place, right? Just to be
Oh,
clear,
okay.
it was never there in the first place.
Mhm.
Chrome isn't there. Golang, which most of the projects are written in, the programming language actually, which is probably super important, is not in the CNCF. So to be clear, not every project in the world belongs in the CNCF.
Mhm.
Right? It just doesn't make sense. So there's a couple of things too. One, there is how the people who write code work with each other. So Istio and Knative are both on GitHub. More than likely, the people who maintain those projects will review your code, and if it makes sense, they'll probably merge it. And is backed by the Apache 2 software license, right? So legally, if you want to fork the code, download the code, modify the code, it's governed by the same license that most of the other projects you're using are governed by, right? So from a software open source perspective, it is super open source. You can do whatever you want. All your freedoms are preserved, right? That's always
Mhm.
that's the license. If someone changes the license tomorrow, more than likely the code you have now with that license, you can use it how you see fit. Now you may have to do some work, but that's the promise of open source. It's not that other people do the work for you. It's that you get the privilege of being able to do the work if you so choose. Now, the overall governance structure, again, these projects are actually fairly mature, right? So in that case, these projects have been working for years under their current model where,
Mhm.
if there's a big feature that wants to change something, then there's some design doc. Now, like Golang and Android and Chrome, Google actually uses these projects in real life, right? That's part of the appeal, right? Google is actually using the Knative API in production for our workloads. So we're going to have lots of opinions about how to keep some consistency there. This is why we try to build good extension frameworks into these tools. And then the last piece there is the trademark. So the last announcement we talked about in this area was the trademark of Istio and other tools like Garrett and so forth. And that's about, I don't know if you remember Red Hat back in the day, but if you were using things like CentOS, there was a lot of work that had to go into making sure, even though CentOS was a rebuild of Red Hat, that you didn't use the Red Hat logos, right? Because of
Mhm.
trademark. That is not covered by Apache 2 and software license. There are laws in some nations where you need to have legal guidance around things like the trademark. So the last thing that we put out was to make it very clear for people how to use the Istio trademark. So for the community, instead of writing a letter to whoever getting permission to use the logo, now you have scalable guidance on how to use the logo, what it means, and how to deal with the trademark. And that's trademark laws, right? So those two things are now covered. In terms of governance, like CNCF, those foundations, and those foundations, they do other work as well, which is joint efforts to promote, joint efforts to ensure a project has longevity. If the original owners, abandon the project, where should it live? So there's good things that the CNCF does, but for a lot of people, the trademark, the legality of usage, how they use it, doesn't necessarily require a foundation to do those things. So I think you as a customer, developer, contributor, you have to make your own decision if that's good enough. But so far, the fact that companies like Solo.io and many others are using Istio within their own product that they sell, I think there's a bit of actual trust. So in theory, people say it not going to the CNCF is bad in theory,
Mhm.
but in practice, you see the results of open source. So you just have to make your own call.
Right.
Right. So since you brought Istio up, Kelsey, uh, so a couple of years ago, I think when Linkerd and Istio went head to head, with Linkerd being on the older version, I think Istio was in the lead, in my opinion. So it had the functionality that all of us were looking for. But right now with Linkerd 2 and being backed by CNCF more than Istio, I think Istio, Linkerd is currently making a good competition to Istio. As we are on the verge of, now we are moving towards the standardizing my service measures. What are your thoughts on Istio versus Linkerd?
So I think in open source, we like to pick winners. I think humans like to pick winners. The number one swimmer, the number one high jumper, the number one everything. Everything is number one, right? Number one, number one, number one. We have like what, over 7 billion people in the world. Imagine if we try to figure out who's the number one human all the time. Life would be terrible. So I think what you have to do is just make sure you understand that in terms of competition, it's always fair. Make your comparisons. It's okay. But there's nothing to win. If Linkerd is really, really good, then everyone should just use Linkerd and everything will be fine. But I also think that there's room for thinking, right? So when Envoy comes out, there was already Nginx, there's already HA proxy, there's already Apache. Why do we need another one? And then here comes Envoy, and Envoy brings a new way of thinking to the problem. Now, we're still moving bytes around. These are still roughly HTTP proxies. Like, we get it. It's roughly the same, but the workflow is drastically different when Envoy came to the table. And Linkerd is out before Envoy. So the fact that Envoy shows up and provides a slightly different way to solve this problem, mainly around how it's configured and mainly around how we think about using it, aka the service mesh. And once we have that, then of course Istio is born, and we start thinking about tight integration with the platform, with Kubernetes in particular, and leveraging Kubernetes style APIs to do declarative config. I think that was the big game changer. So, okay, look, we take that pattern and we slap a label on it called Istio. All right, this is great. Now, if you look at the evolution of Linkerd, they did the right thing from learning, hey, look, there's a different way of doing things. People care about certain aspects. People may care about things like UI. People care about performance in some cases, how you configure it, and things like a control plane versus the, whether it's sidecar linking directly in the app. Same thing is true for Console Connect from HashiCorp. So to me, these are just all good ideas. Luckily for us, we're willing to learn from those ideas and incorporate them. So if Linkerd becomes a thing that we all end up using in the end, I don't know if it matters too much. Who cares? Because guess what? It should be hidden infrastructure. We should hide it. It shouldn't be there.
That's true.
Tell the developers, hey, you're using Linkerd now. We're switching to Istio. Like, does it matter? I just need you to route my traffic and give me a way to configure my particular needs.
Nice. So standardizing is a good idea in the end, isn't it, for service meshes? So it would give people the opportunity to switch between service meshes as they see fit.
We think that in our brains, right? We think, oh, standardizing is going to make things better. In some cases, standards do help us move a bit faster, especially when we can agree, like TCP/IP. And to be honest, the internet isn't standard. There's other protocols there. They're just hidden from you, right? They're encapsulated to travel large chunks of data over large distances. That's not the same thing that you're using to connect to a web server. So there's actually many protocols, even in the internet. So we have this thing in our minds where there's one standard. And also remember, usually there's no universal standard that stands alone, right? There are some people still using HTTP 1.0, some people using 1.1, some people using 2.0. And then there are some people that are ready to move past HTTP altogether into something else. And maybe that becomes HTTP 3. All four of those standards, you hear me, standards, are still being used at the same time. And some people aren't using HTTP at all. So I think when we look at these standards, I think it's more about learning and adopting. So when we see a good pattern that works for everyone, the smart thing to do would be to incorporate the best parts. And if we do it in a consistent way, like XDS protocol for configuring these proxies, then you're right. We can interchange some of the parts without starting over.
Yeah, that makes sense. Just go with whatever works. Yeah. While we're on the topic, Kelsey, I saw your recent tweet on a service mesh without sidecars. I couldn't see the Cloud Next talk yet, but I was wondering, what is that part of the traffic director on GCP, or is that something else entirely?
Yeah, so this goes back to standards, right? So the standards at play are XDS protocol, right? So if you think about Envoy, you think about Istio, all of them implement the XDS protocol, right? So this idea that in order to configure a proxy and all of its extensions, you need some configuration language, right? You need to say, These are your backends. These are your virtual hosts. These are your domains. Here's your certificate. And one thing that's been nice from the Envoy world is the XDS protocol. So that means we can now decouple the control plane from the data plane, right? So whether you pick Envoy, Nginx, gRPC of the question that you're asking. So we have XDS that says, here's a list of your backends. Here's a list of the way to reach them. And here's maybe how to do failover, right? All those things. So of course you can do it Envoy because that's where it comes from. When you look at gRPC, which is also open source, right? gRPC is a way to do RPC between multiple languages, but it relies a lot on code generation. One thing that's nice about gRPC, it handles concerns around things like security, TLS, mutual auth. You can do other things inside of your transport layer. One thing that you can do is what I just call client-side load balancing. I know people want to call it service mesh and all these new terms, but the truth is, it's just client-side load balancing. If I give the client a list of backends, then the client can decide how to send traffic or which one to choose. This is similar to what Envoy does, except for Envoy is in the middle between you, the client, and the server. And in that case, we call it a proxy. But when you handle the same responsibility in your app, some people will look at that as just client-side load balancing. And that makes a lot of sense. So now to answer your question, gRPC is open source, and we can generate middleware to do things like client-side load balancing. And then Envoy or XDS protocol can be implemented in Istio. It can be implemented in Traffic Director. So Traffic Director is more of a managed control plane. If you're familiar with Istio, then you know that the pilot is normally responsible for generating that configuration and streaming it to the sidecars. In this case, Traffic Director is just a fully managed control plane that you don't have to run inside your cluster. You can leave it on the outside. And then gRPC takes the place of Envoy that connects to Traffic Director and streams down the XDS config, or you could have used Envoy. So this is just more about performance optimization, doing things in memory, and getting rid of the sidecar when necessary.
Right.
Okay. All right. So I see a good question that has come up on the latest question. So a person is asking, what would be the best way to do CI/CD with thousands of microservices running on the K8s ecosystem? And he's asking that Spinnaker and Jenkins have some limitations for doing CI/CD.
There is no best way. Haha, there you go. There's no best way. Nothing you can do. Sorry. Here's the thing. If you have a single monolith on virtual machines, maybe in your brain it's easier to think about it, right? I'm going to build the code, I'm going to package the code, and then I'm going to deploy the code, right? Everyone gets that in their brains. It's super easy. There's 5,000 machines. They're all going to run this one app, right? Maybe you do it with some for loop, or maybe you do 100 at a time, but we all understand that, right? Easy. Now you want to do microservice. Why? I don't know, but maybe you want to do microservice. So even with VMs, if I told you that this 1,000 machine need this version of the app, and this 1,000 machines need a different version of the app, now you have to do a little bit of thinking. Now, the whole point of microservices was so you can deploy independently, right? That was the whole point. Like, part of this was I want to be able to develop independently. I want them to be loosely coupled, so no super tight dependencies. Now, they're going to depend on each other. Just like if I have a web API like GitHub, you don't deploy the API for GitHub. You just call it. You're loosely coupled. You don't know when they do deployments. All you know is they have an API version, and you can call it from your application running in your infrastructure, right? That makes a lot of sense. That company does what they do. You do what you do, and then you talk to each other over the network. Makes a lot of sense. For some reason, when people have to do this for themselves, they get confused. There's no reason to get confused. If you have two different apps, they're different. They're loosely coupled. If you have 1,000 clusters with 1,000 apps, then your goal should be to think about those as, to me, independent operations. right? They're independent operations. So if I take the first app across 1,000 clusters, I don't care that there's other apps running on that cluster. My contract isn't at the app level. My contract is at the network level. So if I need to be able to independently deploy and keep them loosely coupled, then I can think about that as maybe the best way is to have 1,000 pipelines, right? So that way each app can be deployed. Where it gets tricky is that most people don't think about backwards compatibility, and they go back to tight coupling, meaning if I change app 1 and I change app 100, you're telling me I have to deploy app 1 and 100 at the same time or it's going to break. Then you're not doing loosely coupled. Now you're making a mess of things trying to find the best way. There's no best way when you do that. If you want to do microservices, if you want to have this kind of architecture, then you're going to have to do some, then you're going to have to do work inside of your CI/CD system to reflect that challenge, meaning I have to have a way to independently deploy 1 and 100. And if you do it right, you'll have some forward and backwards compatibility, meaning if I deploy app number 1, I'm going to support version 1 and maybe version 1.1 so that everything else deployed doesn't know that I've deployed a new version because I'm still backwards compatible. And yes, that's going to put a lot more burden on you to think about versioning, deprecation policies, and so forth, because microservices is not easier. There's a challenge to it, and it's a trade-off that you make.
I see. Okay.
There's quite a number of questions on security isolation and multi-tenancy. Do you have any thoughts on that as to where it's going and where it is right now? As in whether a multi-tenant solution on Kubernetes would be advisable or?
Yeah, so then we have to break that down into 3 parts, right? So that we're talking about the same thing. So some people think about multi-tenancy like App Engine or Heroku. Those platforms, there's only one of them, and everyone uses roughly the same API with their credentials. And you say, hey, App Engine, run my application. Great. It runs your application. And we do it in a way where we can share the control plane. We can share the database where we keep metadata about what's running. And we can share the compute underneath by using tools like gvisor to give us basically a kernel emulator. So none of the apps are talking directly to the kernel. And we also do some hardening at the Linux layer, etc. So we try to make everything safe by doing layered security things, right? There isn't just one switch you do, but we hyper optimize to have true multi-tenancy. Now, when you have your own cluster, Kubernetes out of the box, without doing anything special, you're going to be sharing a Linux kernel, right? So there's definitely things you can do, seccomp profiles and SE Linux and all of this stuff. But what we kind of know is if there's any Linux issues, then a lot of that security can be compromised, right? If there's an Intel bug, maybe some of the security parameters can be compromised because you're sharing a kernel. So no matter how you look at it, no matter how good the security gets at the kernel, is where our risk is, right? That's where our attack vector is. So if you have 1,000 containers on a shared cluster running in the same kernel, that's always going to be your security risk. So can you go and start a business where you let people run random containers in a shared cluster on a shared kernel? That would probably be a bad idea in terms of infrastructure multi-tenancy. Now, you can add things like gvisor, like GKE inside of GCP supports it. Gvisor is open source. You also have Firecracker from the AWS team, which will give you VM level isolation, right? So using some of the CPU things like we do on the cloud to isolate your workloads. Now, there's going to be trade-offs when you do these kind of things, right? Maybe there's an IO hit or something, but there's a way that you can start to get machine level security by reducing how much of the kernel you share between the processes. Now I'm going to say number 2. Number 2 is the Kubernetes multi-tenancy. Kubernetes multi-tenancy is going to be things like namespaces, being able to share secrets, config maps, and so forth. And the attack vector there might be the Kubernetes agent, the kubelet. So even though you're using namespaces, RBAC rules, all of these things, if there are any bugs in the API server, then there is a chance that the Kubernetes agent can be exploited to get other workloads to run on a machine that it should never have done, or to maybe see a namespace that it shouldn't be looking at. So in those cases, then Kubernetes becomes your attack vector if you share a cluster. And the last one, number 3, is your own application, right? You can't just take your app that has one deployment per customer and make it multi-tenant. That's on you. You have to do all the work inside your own API to make that work.
Well, thanks for that. So basically, you need to deal with multi-tenancy and isolation at different layers, right?
Exactly right.
Yeah.
Exactly right.
Right. Guys, if you have any more questions, just drop it on the chat or on the Slido if you have any follow-up questions. There's another interesting one here, which on federation asks, what's your take on maintaining a disaster recovery cluster, say in a different region? They're asking whether if you should go for federation or something else.
So I personally, I don't speak for anyone but Kelsey right now. I personally don't think federation is going to be okay. And the reason why is because I think you need a different API to deal with multi-cluster concerns, right? Just like for a Linux machine, we have systemd, we have bash, we have all these things. That's not the right API to deal with 10,000 machines, right? You just need a different API. So that's why we have Kubernetes. The same is true for Docker. Docker has a different API for dealing with containers on a single host. Kubernetes has an API for dealing with multiple machines in a cluster. And I think that we need a different API, and it can be Kubernetes style, right? Everyone gets confused. It can look like YAML. It can have the same structure, but I think you need a different set of nouns and verbs maybe to describe something for multi-cluster, meaning you might need things like rebalancer. You may, you know, we've been trying this with the Kubernetes API for years, almost 4 years now. And I don't know if this is the right approach. Can you make something work? Of course, I can make a bash for loop work. I don't know if it's the right API. So that's my first comment on the federation. I wish maybe if you just think about it as if I have multiple clusters, what concerns do I have? And then maybe we can start to build tools that don't assume one cluster. So imagine something that runs on serverless platform, managing multiple clusters, or something that runs on a VM, managing multiple clusters. If you think that way, then you can build something that can manage multiple clusters from one cluster, right? But then if that one cluster goes down, there goes your control plane. Second one is DR is not, so there's DR, right? Of course, the disaster recovery. If everything goes down in region A, how do I recover in region B? There's a couple ways to think about that is how much money do you have? If you have lots of money, then some people will say just run both of them in both regions, right? And then the problem becomes whoever's ruffling their shirt, just mute if you can. Thank you. If you're doing DR and you have a lot of money, then you run both clusters with the same capacity, the same number of pods in both regions if you have lots of money. And then you put a load balancer at the top. Like in Google Cloud, we have the L7 load balancer, where you can send traffic to 2 clusters at the same time. That works today. Now, the next question becomes your data. If you're going to try to use MySQL and Postgres, maybe you can pull it off. I have no advice for you other than it's going to be hard. There's tools like Spanner, right? That's meant to be multi-regional. It does, real-time replication. And I think we give, 5 or 6 nines of reliability on it, maybe closer to 5. And then I would say things like object stores for your, your batch data or your blob store. You might want to think about something like cloud storage or S3. Those are all multi-regional built-in replication to reduce your mean time to recovery. If you don't have a lot of money, then your other option would be, maybe you keep a cluster with a no pull of 0. And whenever you need to fail over to the other region, you have to scale up the nodes and then add your workload. So, hopefully you have, you're checking in your configs and you can apply them to the other cluster, but then you have a database problem. So do you want to do a snapshot and restore from backup and then, create your database and inject data? it gets hard, right? But there's trade-offs. Either you want to have very quick recovery, but then it's the same things we're doing in Linux. So it's not a Kubernetes problem by itself. Load balancing is a very old idea and philosophy. So in load balancing, you know what to do if you've done it before in the virtual machine world. And data is data. Kubernetes doesn't necessarily solve the multi-regional data problem. You have to do that. You can run that app on Kubernetes, but it's not going to make the app do multi-region replication. Kubernetes doesn't work at that level.
Hello.
Yep, we can hear you.
Okay, yeah. Kelsey actually added that question. So leaving aside the database problem, thinking that we have that already figured out, right? So as you said, one option would be to like run both clusters in parallel, right? Say that we don't have money and like we have the second state as a passive site, right? So the problem there, not the problem, right? So as you said, when we do a deployment to our primary cluster, we could also like have the same versions being updated in the DR cluster as well. So in case that goes wrong, we could like at the top level load balancer switch to the next region. So it's more the question is like let's say like we are typically running Kubernetes in a LAN kind of environment, so the nodes of the cluster is more optimized to work in a LAN kind of infrastructure. And then when we go to separate cluster itself, so that means like the other nodes are going to be in sort of like a WAN environment, meaning like there's going to be a lot of network delay between those. So in terms of treating them as different clusters, so if we have them in the like same cluster as different nodes, then it might not work really well, because some nodes are in a like a with a considerable network delay. So if we have, let's say,
in my world, I would never let the clusters talk to each other. That's just going to
Yeah.
be a nightmare, right? Just like the internet, right? Like your data center is different from my data center. You never talk to my machines directly. You talk through my load balancer. You don't need to know where I am. Maybe I'm close to you. Maybe I'm far away. So in the DR scenario, the second cluster needs to be its own island. It cannot know about the other cluster at all. It can't depend on the other cluster at all. So if you need 25 different microservices to make your app work, you need to deploy all 25 in each cluster. No talking between the clusters, because you don't, if cluster A is down and then your DR comes up thinking that it can talk to two services in cluster A, the whole thing is broken.
Yeah, that's true, Kelsey. So assuming that we have all the infrastructure and all the services working there, so when we do version upgrade, let's say we do continuous deployment, so it's your take on like we connect to cluster A, and like let's say that's the active cluster, we do the deployment there, and then figure out the cluster B and do the same deployment there. Likewise, like on top of Kubernetes. So like my question was like, okay.
Oh, go ahead. Yeah, so in Kubernetes world, so this is why I hate to say even Kubernetes. I used to do this 15 years ago. 15 years ago, we had some virtual machines in this data center in this city, and we had some more virtual machines in a different city. When you start the deployment, you take care of the, ideally sometimes, because we had more money, we do everything to the backup first. Is everything looking good? Can we do a quick test? Okay, everything is looking good. Everything is starting up okay. Configuration is looking okay. We were more in like, not necessarily active, but kind of, hot, cold, meaning we still paid the money, but we were not using it. We just had extra money. And then if everything looked good there, then you go and do the active one. Now, if the active one starts misbehaving, you have a couple of choices. Either A, you stop and you just roll back to wherever active is and try to figure out how to get a test on the standby to see why it doesn't work. Or if it does work, now you have them both caught up. So now they're both ready to go and you can switch between them, right? But if you don't have a lot of money, one thing you could do in the Kubernetes world, especially if you're doing only stateless workloads, this is a little bit easier when the only things inside of Kubernetes are stateless. So ideally what I would do is I would actually exercise this quite a bit. maybe you save money by not even deploying the other cluster yet. Now you say, hey, our DR is going to be, we're going to try to get it within 10 minutes or maybe within 1 hour. So region A goes down. The way we've been deploying to region A is we always check in our configs. Whatever tools you want to do, GitOps, I don't care. But you have a way where you say everything must be checked in here before it goes to the cluster in region A. Now, if you do that, every change you can actually track through region A. Then at that point, you have the possibility, it may not be a guarantee, but you're going to have the possibility that if region A goes down, I can create region B cluster and then apply from the last commit where all the infrastructure manifests are. And ideally, I'll get all the containers, all the configs set up correctly. And now we go back up and running, and maybe we just have to reconfigure the load balancer to point to the backends in the other cluster.
Yeah. That's almost what we do right now. Yeah. Thanks, Kelsey.
Awesome.
Okay. So another question, Kelsey, that has come up on the questions was that they're asking, what's the next big thing on Kubernetes ecosystem that will shine like service meshes, according to you?
The next big thing. So here's what happens with all technology changes. Everyone just recreates the old stuff. That's all we do, right? So when we went from bare metal to virtual machines, people created virtual network. They took all the security agents from bare metal and made them work on VMware, right? And now that Kubernetes is here, that we got some new ideas. We got things like a scheduler. It wasn't new to everybody, but for some people, that was a new idea and concept. And then we changed the configuration language to reflect the things we want to do to get better workflow. So the core of Kubernetes has done that. And then if you think about some things that aren't really core, like RBAC is just us porting or adopting a standard way of dealing with security, right? We just use a different config language. And if you look at most things that we're doing in Kubernetes, people are taking this platform and they're just building other platforms, whether it's CI/CD, right? What's the difference? You're just running some loops in Kubernetes to do builds. Okay, great. Is that a new revolutionary thing? No. But Kubernetes gives you a different platform to do it on. So you can execute your workloads in a container, and you can use the Kubernetes style API as your configuration to that particular platform. So my guess is most people will see this as a way to just rewrite all the other stuff, right? So everything you use now, everything you wish you were using, they're going to say, oh, this is the same thing, but cloud native. Why is it cloud native? Well, it has Kubernetes API. Oh, okay, I'll take it.
All right. Yeah, makes sense. So another person has asked, they're asking, they want to discuss about the security. They want to ask what are the current limitations, and they're asking how to store secrets securely on Kubernetes. So what is your advice on that?
So Kubernetes is not the same as Vault, right? So Vault was designed specifically for dealing with secret data, right? That's why it has all of these keys. It has a workflow. It has ideas of replication and rotation. It has very granular controls on what it means to store secret data, right? That's what Vault was 100% designed to do. When again, speaking only for Kelsey, when I look at Kubernetes is a API primarily built by default for managing metadata on how to run a workload, meaning what container do you want, how much memory do you want, and what configs do you want? And then we added secrets later to mirror config maps. So then you say, wow, what makes it secret in Kubernetes? Well, Kubernetes tries to protect our objects, whether it's a pod, a daemon set, a config map, or a secret by RBAC. So you may let people see everything but secrets. So at the API boundary, we do have a way to limit who can see certain data. And then you could classify that data as secret. Kubernetes doesn't really care. It's just data. But one way to control access to the data is via some permission set. Okay, this makes some sense. So now we're getting a little closer to Vault. Remember, Vault is 100% designed for this. So now we have a way to limit who can view the secrets. That doesn't necessarily mean that they're encrypted, right? So then later on, Kubernetes added the ability to encrypt certain aspects of data. It's not just for secrets. You can actually encrypt other things. But let's say you wanted to encrypt secrets objects. Now what you can do is have some key or some HSM or KSM, key management service, and use that to encrypt the data before it's stored inside of Kubernetes. Okay, great. So now we have a way to encrypt the data, and then we have a way to limit who can see it. So now you're starting to get a little closer to some of the nice things that Vault does. But the thing you don't really have is like secret generation, meaning going create an IAM account on the fly, or rotating the secret in a way that there's a lease, there's a timeout. There's just so many other aspects into secrets workflow. So how do I think about Kubernetes and secrets? One is in your app, you can always just call Vault, right? Like, hey, just call a secret management tool when your app starts up, get the secrets that you need, and then rotate it yourself. But that means you have to write some new code, and your code needs to know about Vault. That's an option. The other option is to use a sidecar, of course, like console template. That makes a lot of sense. And let that do the hard work. And maybe it writes it into a volume during the init container phase. That's one way. And then I would say the other way is some people think about it this way. And this is how I think about it. Kubernetes is essentially like a cache. So if Vault goes down and I have one Vault install and I have 1,000 clusters and my apps actually need to talk to Vault before they can do anything, this can be a problem if Vault ever goes down. So one way we think about this would be either A, you can run central vaults inside of each cluster that are just copying from the main vault. That's one way. Or some people will say, you know what? I don't want my developers learning about Vault API. I want them just to use either config files or environment variables. And in that particular case, what some people would do is, all right, we're going to build a little tool to synchronize the secrets we care about into their own secret inside of Kubernetes. And that way you start to think about Kubernetes as more of a cache. Where do we do this already? We do this with SSL certificates, right? All these people have these cert manager tools that go to Let's Encrypt. They get the private key, they get the public key, and they put it in a Kubernetes secret so their web server can bind to those, right? We do this already. And that's a form of caching the upstream certificate. So that way we can use it lots of times without keep going back to Let's Encrypt. And of course, Let's Encrypt won't let you call it that many times anyway. So we already use Kubernetes like a cache for all kind of data things like this. So those are my 3 ways of thinking about Vault. Use it directly, use it via sidecar, or you can synchronize secrets across multiple clusters and use Kubernetes as the cache/transport layer. So that way you don't have to think about the Vault API and you have to figure out if that trade-off is the right one for you.
Yeah, that makes sense. So Kelsey, in a follow-up to that, so a lot of people love GitOps and they like to write config files and then store these things and apply. So when Vault coming into the mix, they will have to, like, you cannot store secrets like that. So I remember Bitnami sealed secrets sort of paved the way for, so that you can just have config files for secrets as sealed secrets and then apply to Kubernetes. But with Vault, you manually have to log into the Vault cluster and then you have to add the secrets. So what are your thoughts? Like, is there a better workaround for that? Just like with sealed secrets, where you can just apply a couple of bunch of configs to Vault directly using CLI or something?
This is where I really want people to think deeply. Think. This is just workflow. The only workflow is not kubectl apply. It's just the one everyone's familiar with. So they say make a YAML and then kubectl apply. So everything in their brain is make a YAML, kubectl apply. And then we stop thinking. The truth is, it's just data. There are many ways to get data inside of a cluster. One way is make a YAML file. kubectl apply will take your YAML, convert it, and upload it to the API server. The API server doesn't want your YAML. Now, that's the data that you own. So think of it as data ownership. If I'm doing deployment, if my developer is doing deployment, they own the data. And for humans can write YAML file, check it in, do GitOps, do whatever you want to call it. At the end of the day, all of those things are make YAML file and deploy it. Now, there's another form of data ownership that has nothing to do with creating YAML file first. Think about it. If my data is in Vault, I can write a little tool that says, go to Vault, authenticate, grab these secrets, and put them in this cluster. No YAML, no checking in, because you don't own the data. Vault owns the data, just like when you do Cert Manager. Let's Encrypt owns the data, so you don't need to be checking YAML files. So that kind of data ownership, you can always go back to the database and pull the data, right? So if Vault owns the data, let's say you have one Vault cluster and you have 10,000 Kubernetes clusters. You don't need YAML files. Now what you can do if you want to do the caching technique, the caching technique says, okay, Vault is owning the data for secrets. I'm going to write just one little controller that goes to, hey, Vault, give me these 5 secrets. I know what namespaces those secrets belong. I'm going to use Kubernetes RBAC to protect us, right? Knowing that, I can just easily say, okay, Vault, give me these 5 secrets. And now in my tool, I can loop across all 10,000 clusters and just give them the secret and run every 5 minutes. You change it in Vault, in 5 minutes, I will synchronize to 10,000 clusters, right? You don't need the same workflow for everything. This is why when I hear people say GitOps, they try to make everything GitOps. GitOps is good in some cases where you're generating the data via an artifact that you can check in. Guess where we already do this separation? Autoscalers. When you say autoscaler in Kubernetes, I can have 3 or 10, up to 10, right? There's no YAML file for what it will do next. That means that autoscaler will say, I see that there's a lot of metrics, and now I'm going to generate a new entry. So I'm going to take that component, the replica count, and I'm going to go from 3 to 5. You're not going to check that part in because you don't own that decision. So when you're making these kind of decisions, what does GitOps and what should not be GitOps? Look at who owns the data. In some cases, you're better off just doing synchronization and reconciliation. So every 5 minutes, check if the secret has changed. If it's changed, update Kubernetes. That's the right way. They can live side by side.
I see. Yeah, that makes sense. Thank you, Kelsey. And speaking of scaling, another person has asked, there's horizontal pod auto scaling, which allows you to scale according to Kubernetes level resources metrics or external metrics or whatever we specify. And then there's VPA, which gives you recommendations and tells you what size your scale the pods should be. What are the limits and requests you should specify? So what are your thoughts on how to use these two effectively? Because I believe we cannot use VPA with HPA when it comes to CPU, memory, etc. So what is your advice on using these two effectively?
Yeah, so the way I like to learn these things or think about them is, if I were doing this manually, how would it work? So imagine one person trying to vertically scale and horizontally scale a pod object. It would be really hard, right? Because in one case, you want me to increase the amount of memory to go up or down. And I can only do that by maybe watching the current state of things. And then you have another thing where I'm trying to add or remove the number of pods based on a template that I already have, right? By affecting the current deployment object. And I can go, I can go maybe add or remove a couple of pods. Now imagine those things trying to do the same thing at the same time. It's going to be looking like chaos, right? Because think about the race condition. Let's say I'm out of memory and I have 3 pods. The vertical autoscaler may say, you know what? Let's just recreate the pods with double the memory, okay? And then we will still have 3. And I delete 1. So now we have 2. As I'm recreating, guess who's also recreating? The horizontal pod autoscaler says, hey, I see 2 instead of 3. So it's going to try to create a third one using which template? The old one or the new one? So now we have a big race condition here that if you try to, can we sort it out? I think we can probably sort this out via some complex locking or whatever, right? There might be a way to say, if I'm doing the vertical auto scaling, I need to lock the resource, make the adjustments to the template, and then go and kill all the pods that have the wrong memory settings, and then release the lock. And then the HPA can then examine the new state of the world and make a decision. But this is hard. This is not as easy as people think it is, because if things are coming and going a lot, or you may not even be able to, you go vertical, you give more memory, but it doesn't fit anywhere. And then what does the autoscaler do in this case? So I think it's one of these things that is a complex problem that we need to work out across multiple dimensions. And there's two separate controllers trying to coordinate states in a way that's not compatible with each other. So my guess is it's probably going to be possible. Probably not right now, but you understand the problem now.
Yeah. So currently, I believe then the best way to move forward is like when you run your workloads initially, you don't have an exact idea of how much CPU and RAM it would take. So it's best to run it on recommender mode with VPA, and then once it hits an average load, and if it runs for a certain time and we know the correct requests and limits, then we can switch that off, and then we can switch on to HPA. So is that
that's one way. So depending on how busy your cluster is and how deep you're trying to pack these things, that might be a good way to go. For me, if it was me in production today, that's one option. The other option would be like what most people do, just over provision. If you really know that you don't want any downtime and you don't want complexity, sometimes what I'll do is I might double my need, because most people don't do bench load testing anymore, right? You want to do a little load test in a lower environment. So how much memory to get 1,000 requests per second? Maybe I double that and say, okay, if I can do 1,000 requests with 1 gig of RAM, let's just put 2 gigs just in case. And then we'll run it for 30 days. And then we'll look at the log. We'll look at the graphs. If the graphs say we're only using half, I'm still going to put 1.5 gigs. And that's where I'm going to stop and continue to use HPA. Some people don't like that workflow. I like that workflow mainly because it's the one I'm familiar with. So we'll see if vertical auto scaling can, make me stop doing that.
All right. So speaking of CPU and memory, again, another follow-up to that is requests and limits. So some people put requests and limits as the same, whereas some people put requests to be a bit lower than limits. But however, with requests in place, like there could be limits being higher than requests, there could be problems with nodes running out of some containers using more memory, and we're running into problems. So do you recommend that approach, or do you say requests and limits should be the same?
I mean, the reason why they're different is because it just depends on what you're doing. For example, let's start with the CPU. If you have a box that has 8 CPUs, then you may say, well, I'm going to always use requests, because unless the server has 4 CPUs available for me, I don't even want to go there. So if you already have 8 pods running and each of them have requested 1 CPU, even though they may not be using, we've promised them at least 1 CPU. So the request is a good way to tell the scheduler, like, once you promise those 8 to someone else, do not put me there, because I don't want to be competing with them too much. So if you don't have 4 to just promise for me, then I don't want to go there. So that's why I like requests for everything. Now the limits, CPU, I think most people will get in trouble with CPU limits because they've never used that before. If you think about it, if you do CPU limits and you're one app that is used to maybe bursting on the CPU based on the kernel scheduler you're using, if you do CPU limits, then you might see weird behavior, especially like if you're doing Java, right? So you say, hey, Java, you can have these 2, and I want to limit to 4. But if it's 32 cores on the box, typically Java will see all 32 cores and maybe spawn lots of threads, more than 4, more than its limit. And then what will happen is, if you do 32, you're going to get to your limit, the aggregate of 4, really, really fast. And the kernel's going to throttle the CPU, even though there's more CPU available, no one is using. So in my case, I think for some people, it's probably best to start without the limit for CPU and let the kernel share the CPU for you, because you're probably not going to do a great job, right? Some cases it makes sense, but most people, they get the limit for CPU wrong. Now memory is probably makes more sense to do both. Should they be the same? I think you should give yourself a little bit of room. Hey, I need at minimum, promise me 2 gigs of RAM because of my benchmarking. I found that 2 gigs is, pretty good. I've over provisioned just a little. I shouldn't hit it. If I hit it, that's kind of a problem. But then if I hit it, I do want a little bit of room. So maybe I'll ask for 1.5 gig or give me half a gig more just to have a little room in case I'm producing too much garbage. And then look, I don't want to run out of memory because on most Kubernetes machines, there is no swap space. So once you run out of RAM, that's it for everybody. And that's where you don't want things to go out of control and get a lot of out of memory exceptions. So I do like memory limits, not CPU limits.
I see. All right. That makes sense. So Kelsey, I think the time you allocated is up. But do you have time to run a few more questions? Or?
Yeah, we can take a couple more.
Okay. So another interesting question I see is that people are asking how to do backups on Kubernetes, the workloads running on Kubernetes. So not the etcd, the workloads and the persistent storage and everything. So what are your thoughts on that, advices, if any?
Hey, you got to be real careful here. You need to be very careful. If you start treating this stuff like virtual machines, and you're just going to do a little bit more work, right? So let's say I have a data volume in the cloud. I'm probably going to use the API from the cloud provider to manage the backups of that data volume, right? I know people are trying to add this in the Kubernetes space, right? People are saying, oh, let's make Kubernetes API to do that. Do whatever you want. But if I was really worried about the data, let's say I'm really worried, this is serious business, I cannot play around, I don't want any extra bugs hurting me, then I probably will create the volume ahead of time using the cloud provider API. Say gcloud, create the disk, and then I'm going to set up snapshots and backups on the disk myself, right? Just because I'm really caring about this data. And then I will allow Kubernetes to attach this to a container, right? You could just use the same, volume specification either on a deployment object or pod or whatever you want to do. I say, hey, Kubernetes, just use this volume here when you go and do your work. Now I can control that data volume using the native cloud backup tools. They're going to probably be a little bit more mature, I would guess. And I can also mount them to a VM if I really need to do some intensive work on that data volume, right? Just in case things get crazy. When you start thinking about backups, like if I'm running MySQL, so now we're talking about the application layer. If we're talking about the application layer, then of course you can just call MySQL dump, right? What's the difference? I can just say, hey, Kubernetes, put MySQL here on this node, maybe have a dedicated node or something using some node affinity or taints and tolerations. And then of course I can just always use the same native backup tools. If I'm running Jira, I will export the data. If I'm running MySQL, I'll do MySQL dump. You can still do some of the traditional things, right? You can have your client connect and do some of the same things. You just have to be careful to make sure that Kubernetes doesn't keep moving your workload around and you're not able to do that. So that should roughly be the same as what you're doing today on a VM or bare metal. When it comes to my workload, this is where it gets tricky, because if you try to back up Kubernetes, let's say you go to Kubernetes and says, give me all the YAML files. What are you getting? Right? You're going to be getting a bunch of maybe noise. You're going to get the autoscaler's decisions. You're going to be getting some timestamps that you can't use. So maybe the good backup tools will try to filter. The way I like better is you need to make sure that you have a clean way of bringing up the Kubernetes cluster, all of its extensions and third-party add-ons. And ideally, you have all your configs checked in somewhere. So that way I can create a new cluster from scratch and then add my configs back. And ideally, that's where I should be. So I kind of like the ability to restore versus, I guess, backup and restore, if that makes any sense.
Yeah, that makes sense. And I see that the tool Heptio Velero is making rounds with managing, backing up these volumes. And there are a few others too provided along with volume services like Longhorn and etc.
Yeah, it might. People should try it. It works. It works great. But in the cloud, I've been so used to using the native tools. I just trust them at this point.
Yeah, and a follow up to that. So a couple of people are asking, like this is about cloud created volumes and them being many to many, not many to many, read write many. So I believe one way is that we can spin up an NFS and do that. But what are your thoughts?
I had a tweet the other day that said POSIX and distributed systems don't mix. And a lot of people were very confused by this. Like, oh, what are you talking about? If your library, I don't care what language you're writing, if you believe that everything is a local file, open, write, close, whatever you're doing, and you use NFS, NFS is actually pretty great, right? It can lock, it can have some weird behavior, because if you write, maybe there's some network issue and it doesn't actually write, but your app believes it wrote. Or there might be some delay in either some caching parameter. Lots of things can happen with NFS. NFS doesn't really even have a way to do versioning, right? Maybe your files, it just gets super complicated. So in the distributed systems world, there's more concerns than just mounting volumes and backing them up, right? Because a partial write, what are you going to do with it? It's just junk data now. Maybe you have data corruption. So a lot of times you don't have enough facilities there to do the right thing when you start to think about file management this way. So this is why some people use object store, and I get it. Everyone says, hey, we need to do it the same way for 30 years. Great. If that's you, then do NFS. Good luck with that. Hopefully it works well for you. POSIX, to me, doesn't really explain or highlight the details, right? So if you're doing 2 clusters in 2 different zones or regions, and your NFS server is in one region, then you're going to have high network costs because it's too far away. And then what version of the file are you working with, right? So consistency becomes a problem. This app is reading some old stale data. You have no real way of understanding what file are you reading, what file are you actually writing with a guarantee, strong consistency. You have to think about that. So when we think about distributed systems, this is why S3 and Google Cloud Storage are so important in that use case. If you want to have multiple readers, you need someone to do some kind of universal locking. What version of the file are you working with? Do you want to wait for a version? Do you want the latest one? I think there's just more concerns than can be addressed by POSIX alone, but you have to decide. So yes, in Kubernetes, there's a volume type that will mount NFS everywhere, inject it, and NFS is one of those systems that you can have many readers and writers. But there are some, of course, that are just kind of based on block devices that based on your file system, you can't do that. You can keep trying that. To me, luckily for me, I'm able to separate my data from my workload. Use object store where it makes sense. Use local file system for scratch space when that makes sense. And then just use a real database when I want better data management than just writing files.
Okay. Yeah, that makes sense. So one last question, Kelsey. So one person is asking, do you think more and more companies will consider using Kubernetes to manage Kubernetes, or will they rely on third-party tooling? So I believe they are speaking about probably Rancher running on Kubernetes, and then we manage Kubernetes using that initial Kubernetes cluster, or like cluster API or something like that. So
Again,
what are your thoughts on this?
yes, remember I was talking about federation. Like some people can't think outside the box. They want to do Kubernetes for everything. Kubernetes. Let's use Kubernetes for Kubernetes. Like, what are you talking about? You can make a tool that knows how to provision a Kubernetes cluster. You can make a tool that knows how to split deployments across multiple clusters, right? We can write that tool in any language. We can run that tool from my laptop. We can run it from Lambda. It doesn't matter, right? The tool just needs to know how to take an object and make it reflect into multiple clusters or provision a cluster. We all know how to do automation. It doesn't matter the tool you use to do automation, right? Doesn't make sense. Doesn't matter. Now, if you really, really like the Kubernetes API, because in your brain, you may be thinking people are going to do kubectl apply, right? There's that thinking again. Oh, everything will be kubectl apply, so I have to have Kubernetes API. You can do that. That doesn't matter. So from my laptop, I can make a Kubernetes style API object, and I can teach my little command line tool to just read it. Who cares about Kubernetes API, sir? I don't need it. And I can just read the YAML and then make a deployment run in 2 different clusters. There you go. Am I using Kubernetes to manage Kubernetes? If that makes you feel better, I can take the command line tool, put it in a container, run it inside the Kubernetes cluster. All you're doing is just running a container in a cluster that's using the Kubernetes style API. That is no different from running the same app on a VM, reading in the Kubernetes API. So when you say managing Kubernetes, people just, there's this fantasy about Kubernetes, and I love it. It's great. You can write great APIs. It gives you a great head start, but it's just running an app on Linux that reads from a config over an API. It could have been a local config file. It could be a remote API. There is no difference. So free yourself. If it makes more sense to run this kind of tool centrally from Lambda or Cloud Run, just run it there. It doesn't have to run inside of a cluster.
Yeah. So yeah, so we are using Rancher. So what I have seen on Rancher is that they are using Kubernetes etcd and these operators to actually store the data, and then they are just doing the same thing. I mean, you can take it out and run it separately and use the database instead.
There you go.
Yeah, I get what you mean. Okay, so Kelsey, there are a few more questions, but I think it has gone now. It's 15 minutes late. Do you have more time, or do you want to
Let me.
wrap up? How's the schedule?
I'll take one more.
Okay, one last question. So so they're asking, there's a couple of questions on running Kubernetes and edge like running on low power hardware like Raspberry Pi. There's K3s for that. So they're asking, will there be any motivation for the Kubernetes team to focus on that area to manage on the edge computing side?
I mean, honestly, if I had a Raspberry Pi, let's be honest with ourselves. You only have so much CPU, and you only have so much memory. If you're actually running a workload, and it actually needs CPU and memory, and not just playing around, then you probably want the smallest footprint possible. So I do like what K3s is trying to do, which is say, we just need to get the Kubernetes style API on as small of a footprint that we can. So they had to do some tricks there, right? They had to condense some components, try to think about memory and CPU. I think they did a pretty good job. So that's one way of going about it. We just want that Kubernetes API in more places. And I think now the thing I like about what Rancher was thinking was the implementation doesn't have to be the same. We don't need to port FluentD, Kubelets, etcd, API server. We don't have to have all of that be exactly the same as we do on a large cluster. So now people are thinking. One way to think about this too is, I bet if you really wanted to, you could probably take a single Docker instance and have a little shim that takes the Kubernetes API and just converts it to Docker commands on a single Raspberry Pi. Do you really need a cluster? Right? So in those cases where you just need like a single node, in that world, you might just be better off with something with a Kubernetes API shim that just says, if you give me a pod, I will just run it on a couple of Docker images, net equals host, right? Because who cares? Here's the IP, just talk to it. So we have to ask ourselves, is Kubernetes the right API for all situations? I don't know if the answer is yes, right? Some people, if it's truly edge and you just need a app running on the edge, maybe Docker by itself is okay, right? Just Docker run, it's running, Docker keeps it running, and that's all you need. And then you have something that transports your logs up. You have to make that call, but it's interesting what people are trying to do in this space.
I see.
So
I saw that on one
Nilay.
of the, add on to that. So some people are using K3s and running Kubernetes, and then using Kubernetes to manage these containers on the edge devices, mainly to sort of like manage them through the Kubernetes API. So like sort of like proxying these things to the cloud and then managing it on a centralized plane, because sometimes you cannot really manage them on premise itself. So is that what does that make sense, Kelsey?
So to me, when it comes to multiple clusters, whether you're talking edge or data center, I really do think we just need another tool that sits above all of that. So that tool can just point to Raspberry Pi running some Kubernetes API, whether it's K3s or whatever. If you do it as a separate tool, you can think about the problem very differently. You can just say, register the clusters, register the, whatever it is, it has this much capabilities. And then when you do your deployment, the centralized or whatever control that sits above this API abstraction can now just say, hey, these are where the containers run, and in parallel or one at a time, it's up to you. You can push out updates using the Kubernetes style API. that isn't the only way to do updates, right? There's thousands of ways of doing it. So maybe Kubernetes is the right place to experiment here. But if you think about what the problem is, it's run this app on that device. And if Kubernetes is the right abstraction for you, great. Some people, maybe it's just Docker. Even in this one controller, I can say, I can take this container and generate a deployment config for Kubernetes. And then on the edge where there's only one device, I'll just convert this into a Docker command. What's the difference, right? There's just slightly different APIs for doing the same thing. Now, it's a little different when you want to have a bigger ecosystem, daemon sets, batch jobs, cron jobs. Now, Kubernetes gets a lot more interesting because I can run the different workload types on the edge.
Are you good with that, Nilesh?
Yeah.
Yeah.
Thanks, Kelsey. Thank you. That explains a lot.
Awesome.
Yeah.
I guess with that we can wrap up. Thank you so much, Kelsey, for taking some time off your schedule to come talk to us today. We're really grateful.